Okay, so we'll continue the discussion with TCP. So we discussed that TCP is a full establishes a full duplex connection between the source and the destination, and it is a connection oriented protocol. It's a reliable protocol. It has mechanisms to make retransmissions in case you are losing any of the packets. So that's there because it maintains something as sequence numbers, and we saw how sequence numbers are assigned. Two assignments are there. One is the bytes are numbered, and then they are formatted into segments, and segments will be given randomly. You'll choose a sequence number as the initial sequence number for the segments, and then that will be corresponding to the byte also, and then you pack off these things to the lower layer, that is the network layer. The segments are packed to the network layer where it is encapsulated in the IP datagram and sent over this physical layer. It reaches the destination. The IP datagram will be decapsulated there. It will take its contents and just pass this thing to the transport layer. That's the thing. So connection establishment, the three phases of establishing a connection in a TCP connection are connection establishment, then there is a data transfer, and then connection termination. This is similar to a circuit switching, but you won't be able to show physical things like there is a physical connection as in the case of a circuit switch network. So the connection establishment involves a three-way handshake. Three-way handshake in the sense, initially there is a synchronization sent. Say we saw the TCP segments. We saw the TCP segments where we have this bits, the synchronization bits. So it will be synchronization flag will be set, control bits in the segments. This bit will be set, and a particular segment will be sent by the client to the server, and so this has to be acknowledged, so it has a sequence number. So then again the server will respond with an acknowledgement with a sequence number with the sync set. So ACK sync, so that is the second. In this, the server will respond with a sync ACK set, and again in response an ACK will be sent. The third one might have data. If it does not have data, it is consuming only one sequence number, right? Okay, so that's the key idea there. That is a key idea in TCP. You will have initial handshakes. So this idea here. So yes, slide കാണാമല്ലോ അല്ലേ? You can see the slides. Yes.
Yes, sir. കാണാം.
Right. I just thought. Okay, fine. So it works on a we'll have some ideas that are about port numbers. So here the client side you will have temporary port numbers usually. The server side runs with permanent port numbers. There will be some services which are to be so server side process, it has port numbers. These are in the fixed list, that is the initial list 0 to 1023 list. Those port numbers are there, or some registered port numbers. So this will be known, and this server side process is always ready to accept connections. But as a matter of protocol, it will just say this particular thing is there, such as a condition is just called as a state, which is called as a passive open. Passive open in the sense it is ready to accept any connection from the transport layer, from any client. That is the condition denoted by passive open. So we begin from here, So this is the first step. So the server side process is ready to accept connections from any client, from any over a TCP connection. So that is this is a passive open. So, and again your client side. So the next client side, the client wants to client application layer has to make communication, has to exchange data with the server process. So these two people want to communicate, these two processes want to communicate over a TCP link. Then it issues a what do you say, command, like it issues a direction to its TCP layer, request to its TCP layer, telling that I want to make a connection with this what do you say, host. That means the IP is known, this server with this particular port number. So you will give the port number, the socket number. So this server process, this host running this particular process. So that is the active open case. So once this active open situation state has been reached, then you will exchange the TCP layer. TCP layer will of the client side will send a sync segment SYN because it will set this sync flag 1, and sequence number is randomly selected. The initial sequence number is random. So here the textbook follows the case of 8000. So this has a sequence number. The sync segment has a sequence number. It is sent to the server. The server TCP layer receives it, and then it just processes this thing and says if it is ready, it is already willing to accept connections. It's passive open. So it will respond with a sync plus acknowledgement segment. Sync plus acknowledgement segment because it is an acknowledgement for the sync segment, and it is also showing the so that's why it's called a sync plus acknowledgement. So sync bit will be set, and also there will be the acknowledgement will be cumulative indicating that the server side process is expecting the next segment with the sequence number 8001. So this doesn't contain any data. This sync packet does not contain any data. That's why the sequence number advances only by 1 bit, right? So that is 1 byte. So this is 8001. So this is transported via your IP layer to the transport layer of the client, right? And here what happens, one more thing is set in this. The server side process is also choosing a random sequence number. It is choosing a random sequence number for its segment as 15,000. Again, there is a receive window, that is RWND, that is also there. We had this thing in the TCP thing, that is TCP header format. So receive window, right, receive window has to be set. So that is receive window size. So receive window size is mentioned. There's 5000 bytes. So this is mentioned by the client, by the server to the client to indicate that I can receive these many bytes at a time. If you remember the concept of window, this is the figure which shows the concept of a window. So this is the bytes is a receive buffer and the send buffer. So it says I can buffer 5000 at a time, 5000 bytes at a time, right? That's what. But ultimately it depends on the client side process, because the client is only able to buffer 1000. The client will indicate to the server telling that say I can only buffer what? I can only buffer. So this is a window size. So window size is that. This is receive window size. That's what this point, right? So client can tell I can only set receive 1000 bytes at a time. So that means this will be ultimately dictated by the client. That's what I mentioned in the previous slide. This window sizes are dictated by the client. This is a flow control mechanism. This is a flow control mechanism. So this particular situation, say sync plus ACK, it also will not carry any data, but still it will have one sequence number. It will consume one sequence number. Again, coming to the next thing in the connection is now opened by the transport layer on the client. So a TCP connection is established with the client process and through a particular port number which is already known between them, and an acknowledgement is sent by the client to the server indicating that with the sequence number ACK, so it is 8001, so the next sequence number is assigned, and acknowledgement, this is an acknowledgement for 15001, and its ACK flag is set, and the client is telling, this client is very clever, so this guy is fast enough. It says I can buffer 10,000 bytes at a time. I am okay with 10,000. So this is going to be this. So this is higher than this. So server is very low on resources. That's what. So anyway, this is this reaches the server side, and the transport layer opens. Server side transport layer establishes a connection with its server side process. So now the connection establishment phase is over. So three-way handshake. This is a three-way handshake involved in TCP. So sync plus acknowledgement and acknowledgement. Now in some, so usually this ACK segment does not contain any bytes. ACK segment does not contain any bytes. But in some implementations of TCP, the first data bytes are sent along with this. In that case, it will consume more than one sequence numbers. Okay, next sequence, suppose 10 bytes are sent along with this, so the next sequence number will be 8011, right? 8011 will be the next sequence number of the segment sent from the client process, client side. Else it will consume only one sequence number. So we need to keep track of the sequence numbers, because that's part of the making sure that any packets or any segments which are received out of order, they can be rearranged based on this. The bytes are also numbered, the sequence numbers are also there. So that's the connection establishment phase. Now we go to the what is the next phase, where we have the data transfer. So data transfer is normal. So here the data transfer happens. So connection establishment phase is over already. Now we are in the data transfer phase, where there is the data being transferred with 8001 again. So this is following this this continuing with this. You can use 8002 here in this along with this acknowledgement. It is sending this data, and we'll talk about this push P flag later. So it is transported to the server side process. So this is sent 8000, I think 1000 bytes are sent. So the next sequence number from the client side will be 9001, and acknowledgement for 15001, right? It's mentioned again. It doesn't have anything to send. At 15001, it's being sent again, because the server the client expects, if any data is coming from this side, it expects a sequence number of 15001. That's why it's mentioned. You don't send me 15002. I'll assume that some frame has been lost. So next, remember, next thing you have to send me is a packet with this with segment with the sequence number 15001. That's what this is telling. Don't send me any other number. If you send me any other number, I'll assume that I have lost some segments have been lost. So this is a reminder in one way. So it's a normal course of action. Right, we can figure out what happens if something is lost. There will be wait periods, then there will be retransmissions, just like what we discussed in the data link layer. All these things are working on sequence numbers. We chose sequence numbers there, 0 and 1. Same concepts can be expanded to this, right? Now here this this process, this shows that this arrow is put incorrectly. This should be in this direction, right? So this is sending some bytes with the sequence number this. Now let me, before we go to this, let's discuss what about this. This is acknowledgement flag. This is an acknowledgement. This push is P. So P is standing for push flag. So push flag, if you recollect the push flag, PSH, request for push, and again there is urgent. So two things are there. Okay, so this push flag, it's deliberately, it's a case, deliberately it is a case to make sure that there is some sort of priority given. So that is say for instance your client has some thing very urgently, not urgently, I won't use the word urgently, say it wants to send some amount of data, a big block of data to the client has to send, the client application program has to send a large block of data to the server side process, and say it has to be immediately done. So server side application program. So in that case, what happens is the client application layer program will just push this block of data to its transport layer, and it will indicate that this has to be pushed immediately. This is a high priority thing. So suppose the block of data is much smaller than the maximum size of the TCP segment, say maybe only 10 bytes, and so if the push flag in the application layer is also set, so it doesn't require, so push there is an indication on the application layer that this is to be dealt, this should be dealt immediately. So the application program can make a request for push. That will be the absolute term. It can make a request for push. So the TCP will set the push flag, and for example, if the TCP segment can carry 1000 bytes, but it has received only this 10 bytes, and with the request from the client application layer process that this has to be pushed, means the client TCP layer will not wait for remaining bytes to fill up in its segment. It will just immediately dispatch this thing. It will just immediately dispatch this this particular this particular byte will be immediately sent. To this client side or server side, and the server transport layer, when receiving this thing, will see that the push flag has been set. It won't wait for remaining any of these bytes to come in. It understands that these 10 bytes which has been sent by the client application layer process have to be immediately sent to the server side application process. These are requiring immediate attention. So the push flag is for that purpose. Now it's up to the transport layer to whether to do this or not, whether to have acknowledge, whether to provide a push response to this respond to the push request issued by the application layer process. That's up to the TCP layer. TCP layer can or cannot. So it depends on how you configure your application program. Some responses had to be immediately conveyed to the client application layer process. So, and your transport layer should acknowledge that. That's what. So your transport layer should set this push flag and immediately send this thing. Whatever, even if it is of fewer bytes, say this can take say 1000 bytes, but if there are only 100 bytes, still it has to send, and the transport layer also should not wait for this many. It has to be understood that this is requiring immediate attention of the server side process. That's the purpose of the push flag. Then there is another flag which is called as an urgent flag. U is an urgent flag. I should have put this thing here. Urgent flag, urgent pointer. And if you see here that there is urgent pointer location also, right? Two things. There is the control bits and the urgent pointer. These two. Control bits ilani URG, SYN, ACK ellam varunathu, right? So this is another mechanism where, say for instance your server's client side process has to send some amount of data which is to be seen urgently by the, what do you say, usually the process is that the bytes are arranged in the same sequence as they come in from the application layer process. Suppose your application layer say needs to urgently send some bytes that are to be, say that require some special treatment at the application layer on the server side. So it can make a urgent request to the TCP, a request for urgent. This is an urgent thing. So and so the client side tells its TCP layer, see these many bytes, say for instance this 100 bytes are to require urgent attention of the server side application process. So what the TCP layer does is that it will put these 100 bytes at the first portion of the segment. So and then it will set the urgent pointer to 100, telling that the first 100 bytes are the urgent bytes, and indicating, so the urgent pointer is set to 100, indicating that this is the end of the urgent bytes. That is what urgent bytes are ending there, and the first 100 bytes are urgent bytes, and it will also set the urgent flag. So that means what happens, so if you have 1000 bytes in the segment, and the first 100 bytes are urgent, they are put in the segment in not in the correct sequence, they are just put there in the initial portion, so that it will be presented like that itself to the application layer. So remaining non-urgent, you say low priority things. So this is not a, you can't strictly say this is a priority thing, rather it is it's just a service, like it is it ultimately depends upon your client server side application program to decide what to do with this urgent bytes. Okay, because the application layer program on the server side may ignore it. It depends on how you have configured how you have designed your application layer process and the server side. The client process might think that this is a very urgent thing to be informed to the application layer program, but the other side may not think like that. So this is the discussion about what do you say, urgent pointer and urgent flag. So your urgent pointer will indicate the end of urgent bytes, and the urgent flag is also set. Push is some things which require immediately to be pushed from the client side transport layer to the server side transport layer, and this has to be immediately presented to the server side application process. Right now here if you follow this thing, there is a data being sent from this direction as well, the server side process. There is piggybacking. You see that this is an acknowledgement for the first, this is a cumulative acknowledgement. Say the server side is acknowledging the 10,000 bytes, not 10,000, the bytes from 8001 to 10,000. So it says the next byte I expect is 10,001 and the sequence number 15,001, right? It is following this thing, right? And it says my receive window is 3,000. This guy is very smart. This says I am 10,000, right? And it sends some data also, right? It acknowledges this with this acknowledgement 17,001, telling that the next byte I expect is this 17,001. It's starting with 17,001, right? The sequence number should be 17,001. That's the indication. It's an acknowledgement. Acknowledgement bit is also set, right? So we are done with the data transfer. Now once the data transfer is over, connection can be kept in a suspended state. There are different states for this actually for TCP connection. We will see in a Wireshark data capture session how it is done. So anyway, we will talk about the natural course where there is a connection termination. Connection termination is also a three-way handshake process. Here there is an active close command. Is this the time? Is the time over, Sanjana? Class in the summer? Yes. Right. Okay, I just need 10 more minutes to very peacefully discuss that topic. So we'll continue with it in the next day. Okay, we won't rush through this connection termination. Next day I'll just review this connection establishment and data transfer, and then we'll discuss the connection breaking down the connection, and also see a Wireshark session as to how it is done in real time. We'll see a Wireshark session live. So assignment ഒരെണ്ണേ തന്നിട്ടുള്ളൂ ഇതുവരെ. രണ്ടാമത്തെ അസൈൻമെൻറ്റ് എന്താണ് വേണ്ടതെന്ന് ഞാൻ ആലോചിച്ചുകൊണ്ടിരിക്കുകയാണ്. അപ്പോൾ നമുക്കത് ചെയ്യാം, എന്തെങ്കിലും ഒരു പരിപാടി ചെയ്യാം. വയർഷാക്ക് എല്ലാവർക്കും ലാപ്ടോപ്പ് ഇല്ലെന്നാണ് എനിക്കിപ്പോഴും മനസ്സിലാവുന്നത്. സ്വന്തമായിട്ട് കമ്പ്യൂട്ടർ ഇൻ്റർനെറ്റ് കണക്ഷൻ്റെ പ്രശ്നമൊക്കെ ഉണ്ടെന്ന് മനസ്സിലാക്കും. സോ ഐ ഡോണ്ട് ഇൻസിസ്റ്റ് ഓൺ ദാറ്റ്. Maybe you can suggest, rep, please ask the class what should be the second assignment. It shouldn't be in the answer that we don't need a second assignment. Rather, you can let me know what is the majority opinion. Wireshark session വേണോ, അസൈൻമെൻ്റ് ആയിട്ട് വയർഷാർക്ക് സെഷൻ ആണെങ്കിൽ ഒരു TCP ക്യാപ്ചർ സെഷനും അതിനെക്കുറിച്ച് കുറച്ച് കമൻറ്റ്സ് എഴുതാനും, DHCP ക്യാപ്ചർ സെഷൻ, പിന്നെ നേരത്തെ അസൈൻമെൻറ്റ് ഫസ്റ്റ് ക്വസ്റ്റ്യൻ സെറ്റ് വെച്ച് കഴിഞ്ഞു, അത് അസൈൻമെൻറ്റ് 1. അസൈൻമെൻറ്റ് 2 ഇങ്ങനെയാണ്. അല്ലെങ്കിൽ പിന്നെ പതിവ് പോലെ കഥ എഴുത്ത്, കോപ്പി എഴുത്ത്, അങ്ങനെയുള്ള പരിപാടിയേ ഉള്ളൂ. വേറെ എനിക്ക് ഒരു മാർഗ്ഗമില്ല. I just turn off this recording.